Hi, I'm Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today I wish to tell about the lasing action and ruby laser. So, in this session, we are going to cover the topics lasing action, types of lasers, and then ruby laser. In the ruby laser, we are going to see the construction of ruby laser and working, and then what are the drawbacks in the ruby laser. So, lasing action. So, after completion of lifetime of electrons in the metastable state, they fall back into the lower energy level or ground energy level by releasing energy in the form of photons. So, this process of emission of photons is called spontaneous emission. So, after completion of lifetime means 10 power minus 8 seconds. So, the atom in the excited state will be stay up to 10 power minus 8 seconds. Then after it fall back to the lower energy state by releasing some energy in the form of photons. So this process of emission of photons is called spontaneous emission. So when this emitted photon interacts with the electrons in the metastable state, it forces that electron to fall back to the ground state. So already we have seen that what is the metastable state. So here in the spontaneous emission, it releases some photon of energy. So that emitted photon interacts with the electrons in the metastable state and it forces that electron to fall back to the ground state. So as a result, two photons are emitted. So this process of emission of photons is called stimulated emission. So here, when the electron transits to lower energy level to higher energy level, then two process of emissions will happens. One is spontaneous and then one is stimulated emission of radiation. So in the spontaneous emission, after completion of the lifetime of an atom, the atom or the atom or electron transits to the lower energy state by itself. So in this way, so in this transition, it emits some radiation. So another way of process, the electron which is at the excited state, before the lifetime of that electron, it absorbs some energy and gets stimulates, transits to lower energy state by emitting two photons. So that is called the stimulated emission. So when this photon, that is when the photon released spontaneously, that emitted photon interacts with the electron in the metastable state. So it forces the electron to fall back to the ground state. As a result, two photons be released or emitted. So this process of emission of photons is called the stimulated emission. So when these photons again interacted with the electrons in the metastable state, so that is in stimulated emission of radiation, two photons are emitted. So these two photons again interact with the electrons in the metastable state. They forces two metastable state electrons to fall back to the ground state. So as a result, four electrons are emitted. So likewise, a large number of photons are emitted. As a result, millions of photons are emitted by using small number of photons. So here, two photons are emitted through the stimulated emission of radiation. So these two photons again interact with the electrons at the metastable state, then it fall back to the ground state. While it is fall back to the ground state, it emits four photons. So these two photons, while coming to the lower energy state, it emits four photons. So likewise, large number of photons are emitted. As a result, millions of photons are emitted by using small number of photons. So this is the lasing action. So next one, we shall see the types of lasers. So there are many types of lasers we are using in medical field, industrial, and in so many areas we are using this lasers. So what are the types of lasers? What are the types of lasers? So there are many number of laser types. So here we are going to see solid state laser, gas laser, and then semiconductor laser. This semiconductor laser also called as diode laser. So solid state laser. Solid state lasers have lasing material distributed in a solid matrix. Suppose, for example, the ruby or neodymium, yttrium, aluminum garnet lasers. We can take as an example for the solid state lasers. So, in this ruby laser, it emits 6,943 angstroms, whereas neodymium, yttrium, aluminum garnet laser, it emits infrared light of 1.064 micrometers. Then coming to the gas lasers have lasing materials such as helium neon or CO2 carbon dioxide. Here, helium neon laser, it emits 6,943 angstroms, whereas CO2 laser, it emits energy in the far infrared 10.6 micrometers and are used for cutting hard materials and medical purposes. We use this type of lasers. Coming to the semiconductor laser. In this semiconductor laser, sometimes we call this as diode laser, and they are not solid state laser. These electronic devices are generally very small and use low power. Okay, so semiconductor lasers, sometimes called as a diode lasers, and they are not solid state lasers. They are not solid state lasers. So here, the electronic devices generally very small, and then they use low power. They use low power. So they built into large arrays. For example, used as writing source in some of the laser printers or compact disc players like that. So in the solid state lasers, first we see the ruby laser. So the ruby laser was the first solid state laser which was fabricated by the Weiman. Ruby laser was the first solid stated and it was fabricated by the Weiman. So ruby laser is a solid state pulsed 3-level laser. Solid state pulsed 3-level lasers. So it consists of a cylindrical shaped ruby rod. So there is a cylindrical shaped ruby crystal rod which have the length varying from 2 to 20 centimeters. 2 to 20 centimeters and the diameter varying from 0.1 to 2 centimeters. And the end faces of the rod are highly flat and parallel. Highly flat and parallel. So one of the faces is highly silvered and other face is partially silvered. So that it transmits 10 to 25% of instant light and reflects the rest so as to make the rod resonant cavity. So basically, ruby crystal is made up of aluminum oxide which is doped with 0.05 to 0.5% weight of chromium oxide atoms. So these chromium atoms serves as activators. So here in this ruby laser, so there is a ruby crystal rod length varying from 2 to 20 centimeters and in diameter 0.1 to 2 centimeters. And the end faces of the ruby rod is flat and parallel. One side is fully polished and another side is partially polished. That is, one side is highly silvered and another side is partially silvered, so that it transmits incident light up to 10 to 25%, and then it reflects the rest of the light to make the rod resonant cavity. So that here in the ruby crystal rod, it is made up of aluminum oxide, and this aluminum oxide will be doped with the 0.05 to 0.5% of chromium oxide atoms. So because of doping these chromium oxide atoms, it serves as a activator. So because of here the aluminum oxide is doped with the chromium oxide atoms with a percentage of 0.05 to 0.5%. So here these chromium atoms acts as activators. So due to presence of 0.05% of chromium, the ruby crystal appears be pink in color. So the ruby crystal is placed along the x-axis, that is in the axis of a helical xenon or krypton flash lamp, which have of high intensity. So the ruby crystal is placed along the axis of helical xenon or krypton flash lamp of high intensity. So this is the ruby laser. So the ruby crystal rod. This is a ruby crystal rod. This is ruby crystal rod, and it is made with aluminum oxide plus chromium oxide. So 0.05% of chromium is doped with the aluminum oxide. So this ruby rod is made with aluminum oxide, which is doped with chromium oxide. So the two end faces are flat and parallel. These two end faces, the crystal ruby rod end faces are parallel and flat, and one face is highly silvered, one face is highly silvered face, and another face is partially silver. Another face is partially silver, and it is placed along the axis of helical xenon flash tube. So this is the helical xenon flash tube. Helical xenon flash tube. So this ruby crystal rod is placed along the axis of helical xenon flash lab. So the construction is, ruby is a crystal of aluminum oxide in which some of aluminum 3 plus ions are replaced by chromium 3 plus ions. When the doping concentration of chromium 3 plus is about 0.05, then the color of the rod, ruby rod, becomes pink. So the active medium in the ruby rod is chromium 3 plus ions, because chromium ions acts as an activators. In ruby laser rod, of 4 centimeters long and 5 millimeter diameter is used, and the ends of the rod are highly polished. Both ends are silvered such that one end is fully reflecting and other end is partially reflecting. So the ruby rod is surrounded by helical xenon flash lamp, which provides optical pumping to raise the chromium ions to upper energy level. So here we are using optical pumping. So through the optical pumping technique, we use to raise the chromium ions to the upper energy level. So the xenon flash lamp, which emits intense pulses, lasts for only few milliseconds, and the tube consumes several thousands of joules of energy. So in this several thousands of joules of energy, it uses only a part of energy. Only a part of this energy is used for pumping the chromium ions to the higher energy levels. So the remaining heat, that remaining energy or the rest will goes as heat to the apparatus, which should be cooled with the cooling arrangements. So the xenon flash lamp tube emits intense of pulses, so that intense pulses last for only for few milliseconds, and the tube consumes several thousands of joules of energy. In this thousands of energy, only a part of energy is used to pump the chromium ions. The remaining energy will be used to, or rest will be heat up the apparatus so that it should necessary. Only a part of energy is used to pump the chromium ions. The remaining will heat up the apparatus. So it should be cooled with the cooling arrangement. So coming to the working, ruby crystal is made up of aluminum oxide as a host lattice with a small percentage of chromium ions replacing aluminum ions in the crystal. Chromium acts as a dopant. A dopant actually produces lasing action while the host material sustains this action. So the pumping source for ruby material is xenon flash lamp, which will be operated by some external power supply. So chromium ions will respond to this flashlight having wavelength of 5600 angstroms. When the chromium ions are excited through the optical pumping, the chromium triplets ions are excited to energy level E3. From E1, the population in E3 increases. So the chromium ions excites to, through the optical pumping, the chromium ions excites to E3 level from E1 level, so that the E3 population will be increases. So chromium ions stay here for a very short time of the order of 10 power minus 8 seconds. So chromium ions, after exciting to the higher energy state E3, there they would stay up to 10 power minus 8 seconds. So after that, they drop to the lower energy state E2. They drop to the lower energy state E2. So E2 is a metastable state. So which have the lifetime of 10 power minus 3 seconds. Here the level E3 is rather a band which helps the pumping to be more effective. So the transitions from E3 to E2 to E3 to E2 are non-radiative in nature. So, radiation-less transitions between E3 to E2. The transition from E3 to E2 or non-radiative transition. So during this process, heat is given to crystal lattice. So hence, cooling rod is an essential feature in this method. So this photon travels through the rod, and if it is moving parallel to the axis of the crystal, it is reflected back and forth by the silvered ends until it stimulates an excited ion in E2 and causes it to emit fresh photon in phase with the earlier photon. So this photon travels through the rod, and if it is moving parallel to the axis of the crystal, it would reflect it back and forth by the silvered ends until it stimulates an excited ion in E2 and causes it to emit fresh photon in phase with the earlier photon. So this stimulated transition triggers the laser transition, and this process is repeated again and again because that photons repeatedly move along the crystal being reflected from its ends. So the photons thus get multiplied and we get the stimulated emissions. So when the photon beam becomes sufficiently intense, so such that the part of it emerges through the partially silvered end of the crystal. So this is the energy level of the ruby crystal. So 3-level region. So that's why chromium is excited to higher energy state E3. So after the lifetime of an there at E3, it spontaneously transits to lower energy level E2, which is a metastable state. So the transition from E3 to E2 is a non-radiative transition. So there it gives some heat. So during this process, heat is given to the crystal so that there is an arrangement to cool the rod. So the photon travels through the rod and it is moving parallel to the axis of the crystal. So it would reflect it back and forth because of there is a partially and fully polished surface of ruby rod is there, so that it reflected back and forth by the silvered ends. So until it gets stimulated. So when it gets stimulates, excited ions in the E2 and causes it to emit the fresh photons. So any one of the case, if the stimulated transition triggers the laser process, so the emitted photon moves parallel to the axis of the crystal and it get reflected back and forth because of the silvered ends until it stimulates and an excited ion in E2 and causes it to emit fresh photon in phase with the earlier photon. So this stimulated transition triggers the laser transition, and this process is repeated again and again because the photons repeatedly move along the crystal being reflected from its ends, so that the photons are getting multiplied. So when the photon beam becomes sufficiently intense such that part of it emerges through the partially silvered end of the ruby crystal rod. So what are the drawbacks? What are the drawbacks here? So the laser requires a high pumping power because the laser transition terminates the ground state and more than one half of the ground state atoms must be pumped to the higher state to achieve population inversion. The efficiency is very low. Only the blue and green components of the flashlight are utilized and the remaining are unused. Ruby laser is a pulsed laser. The laser output is not continuous but occurs in the form of pulses of microseconds. So these are the drawbacks in the Ruby laser. So this is all about the Ruby laser. So a chromium ion excites from E1 energy state to E3 energy state. So after 10 power minus 8 seconds, it would transits to lower energy state E2. E2 is the metastable state. So here the transition is non-radiative transition. So and here in the metastable state, the photon gets interacts because of the partially and the fully reflecting mirrors, fully crystal rod faces at the end faces of the crystal rod, as it is fully and partially polished, so that the emitted photon would reflected back and forth. So here it would reflect back and forth. So in this way, the emitted photon triggers, or the chromium ions get excited from E1 to E3. It stays up to 10 power minus 8 seconds at E3 energy level. Then spontaneously it transits to E2 energy level metastable state. That is metastable state. Here the transition is radiationless transition. So this emitted photon gets stimulates with another, and then any one of the case it gets triggers the stimulated emission, so that the stimulated transition triggers the laser transition, and then the process is repeated and repeated again. So because the photons repeatedly move along the crystal being reflected from its ends. So when it gets multiplied, if the photons are sufficiently high, so when the photon beam becomes sufficiently intense, then part of its emerges to the partially silver end of the crystal. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.